with the interest rate specific derivative instruments, where our focus is primarily on interest rate caps and interest rate floors, and combining these two we will even create what we call as collars. So these are the three instruments which are of more important for us. Of course, once we understand the cap and the floor, we can very well talk about the collar on the same lines. Now, whenever we talk about interest rate cap, as the word itself is saying, I am putting a cap on the interest rate. So it's as good as saying, let's say I am borrowing. Let's say I am borrowing at a floating rate. Now, once I have borrowed at a floating rate, at regular intervals, probably on a monthly basis or quarterly basis, whatever is my payment period, at regular intervals, depending on what is the floating rate that is persisting at that point, my payment would be depending on that. Rather than that, if I take a cap, it's as good as saying, okay, as long, let's say I have set the cap at around 8%. It's as good as saying, if the interest rate, if the floating rate is less than 8%, I'll still pay the floating rate itself. But if the floating rate crosses 8%, I'll only pay 8%. That is how we are, in a crudest sense, I can talk about an interest rate cap in that typical manner, which means probably it is looking more like a call option itself. If you remember the way we talk about a typical call option, if the stock price is less than, let's say, a strike price of 100, I will purchase it at the stock price itself. But if the stock price goes greater than 100, I will purchase the stock at 100 only. That is what is the typical definition of a call option. The similar logic is applying on the interest rates, which is what we call as the interest rate cap. In other ways, whatever, in case the stock price is greater than 100, then we talk about stock price minus 100 is the payoff, whereas the stock price is less than 100, 0 is the payoff. Same logic again, if the market rate is greater than the strike rate, which is 8%, then the difference between the two is the payoff, otherwise 0 is the payoff. So probably what you can see is there are a lot of similarities that are existing between the interest rate cap and probably call option on a stock, right? Same logic goes with interest rate floor. It is similar to that of a put option on a stock, which means when the market rate is lesser than the strike rate, there is a benefit which is to the extent of strike rate minus the market rate, whereas when the market rate goes above the strike rate, the payoff is going to be 0, which is similar again to the concept of the put option. But the only thing is, here we talk about a series of payments against one single fixed rate. That is the major difference that we get. Otherwise, even this is same as call option on some reference rate, right? If the actual market rate is greater than the reference rate, the difference between the two rates multiplied by the notional principal amount is what is the benefit that the buyer, call option buyer, is typically getting. But in this case, the prime difference that comes out with respect to a cap is, in case of a cap,